Okay, in today's lesson, we're going to talk about the different special products that are available. When you're factoring, it's kind of like when you recognize it, you have a little shortcut instead of having to factor it out your normal way. So let's look at the first square of a binomial. So if I've got a binomial, a plus b, and I'm squaring it, then you can just take the a and square it, the b and square it, and then in the middle, multiply a times b times 2. Okay, you're like, oh, okay, Miss Lane, this a and b, it's all confusing. So let's look at the real one, okay? So you got x and plus 5. So this is a and this is b. So first you're going to square your first term, x squared, and then we're going to square the 5. And in the middle, it's 2 times x times 5. Well, 2 times 5 is 10, times x would be 10x. All right, so we could still, factor it out. We could still say, because this is the same thing as x plus 5 times x plus 5, right? So we could still say 25 over 10 what am I doing? I'm trying to factor. It's already factored. We could just distribute it out. There, x times x is x squared. X times 5 is 5x. And 5 times x is 5x. And 5 times 5 is 25. Combine your like terms, you get x squared plus 10x plus 25, which is what we got. So it's just a shortcut. When you recognize you're squaring a binomial, just square the first term and the last term, and then in the middle, multiply the terms, and then multiply that by 2. Okay? All right, so if you're looking at the other example, multiply your first term, you square your first term, so 2x squared. So that'd be, 2x, and then square it, so it'd be 4x squared. And then our last term is going to be negative 3. To take the sign with it, negative 3 times negative 3 is positive 9. And in the middle, we're going to say 2 times 2x times negative 3. So that'd be 2 times negative 6x. So in the middle, we're going to put minus 12x. And that's your factor. Your polynomial.
Miss Lisa Simmons.
Yes, sir.
All right. So let's look at some more examples. Okay. 7 plus x. Square the first one, square the last one, and then multiply the two of them and times 2. So 2 times 7 is 14x. Okay. Square the first one, square the last one, and then 2 times 4x times y, negative y. So it'd be 16x squared. My last one would be negative y squared, so it'd be plus y squared. And then 4, take the first term, covering up some of this stuff, aren't I? Your first term times your second term, so that'd be 4xy. and then double it. So it's plus 8x. Now, did you notice something? I wanted to see if you did. What happened there? Isn't this the same thing as negative 1y? So this should be sorry, y'all. My pen's not working very well. Negative 1y. So 2 times 4 is 8 times negative 1 is negative 8. And then your x times your y. So this should be negative. Come on. Okay. Alright. So we're going to take the square of your first one and the square of the negative 3. So 49x squared. My last term will be positive 9. And then 2 times 7x times negative 3. So 2 times 7 is 14 times negative 3. It's negative 42x. And y'all, if you want to check it, if I did this, which is what that means, if I distribute, okay, minus 21x, then minus 21x, plus 9. See why they're saying double it? Because it's the same thing, right? So 49x squared minus 42x plus 9. Okay, so it's just a shortcut. So square root of the first one, square root of the last one, and then 3mn times 2, so it'd be 6mn. So it's a lot quicker than doing all of this, all right? Okay. All right, so let's look at our next pattern. I kind of call these special products. The next one's sum and difference pattern. So if I've got a binomial and they're the same except one's plus and one's minus, then it'll always be a minus, and you just take the square of A and the square of B. So it's x plus 3 and x minus 3. They have to be the same, just different signs, okay? So your answer is always going to be a minus. It's always. And you square the x and square the 3. Okay? So this one, we would square the x, put a minus, and square the 5. Okay. And let's just prove that. T plus 5 times t minus 5. So t times t is t squared. T times negative 5. And then 5 times t. So see, this is where they cancel out, isn't it? Minus 25. These cancel out, and you're left with that. All right, let's do some examples. All right, they're the same. It's just one is plus and one is minus. So square the x, always a minus. Square 10, 100. Okay. Square the x, so 2x squared minus 1.5 squared. So it would be 4x squared minus 2.25. Over here, we were taking factors and writing the polynomial for it. So now, right, our next pattern is difference of squares. All right, so this is when you have a binomial that is subtracting two perfect squares. So remember, like 36, that's a perfect square because it's 6 times 6. 49, 7 times 7. That's a perfect square, right? All right, so like if I've got x squared minus 9, that's a perfect square. 9's a perfect square. Okay, so it would be this, and then we can break it down based on what we just did. One's plus and one's minus. So this is a perfect square and this is. Okay, so this is kind of like going backwards from what we just did. So it's x plus 5 and x minus 5. Okay. One of your binomials is plus and one's minus. One's the sum and one's the difference of those perfect squares, the square roots of those perfect squares. So the square root of this would be 2z, and the square root of 1 is 1, so 2z plus 1, 2z minus 1. All right. Let's go on. You can pause this and work it and then see if you're getting it right. So, taking the square root of these, right? One's going to be plus and one's going to be minus. So, x, square root of x squared is x, square root of 36 is 6. One's plus and one is minus. Square root of 100 is 10, because 10 times 10 is 100. Square root of m squared is m, because m times m is m squared. So before they gave us the factors when we were writing the polynomial, now we're just going backwards and they give us the polynomials and we're factoring it. And again, these are all shortcuts. You can go the old way and do them as well. Okay? And y'all, these always a minus, okay? If that was 9n squared plus 16, it wouldn't work. We couldn't do it. We'd have to factor it out the other way, because it's called a difference of squares, okay? So one's going to be plus and the other one's going to be minus. So we'll take the square root of both of them. So this would be 3n and this would be 4. Okay. It's kind of a mess there. 3n minus 4. All right, so that's difference of squares. Our next pattern is a perfect square trinomial. Trinomial is 3 terms, right? So they're giving us the trinomial, and we're gonna factor it and simplify it. Because remember, at the beginning, we'll take the polynomial and write the factors. So we're just kind of going backwards. And when you're looking at these, look to see, okay, I've got a trinomial, but are these perfect squares on the end? Okay, so, all right, so a plus b squared. Remember that we said for these, if we were going to take this and write it, the polynomial, you would take the square of a, the square of b, and then it'd be 2 times a times b. So if I'm given this, then I notice that these are perfect squares. So this is x, and this is 3. If I say 2 times 3 times x, that gives me 6x. So that means that I could just write this as x plus 3 squared. The key is these a and b has to be perfect squares. So I have perfect squares here, so it's going to be n, the square root of 16 is 4 squared. And just remember, the middle is 2 times a times b, so a and b is 4n times 2 is 8n, so that checks. All right, so are these perfect squares? Yes. The perfect square of 4x squared is 2x. And then the perfect square of 9 is 3. Now, you say, is that going to be plus or minus? Perfect square of, so let's talk about it a little bit. So you notice it's got a minus here and a plus here. So our question is, what do I put here? Well, we know that the square root of 9 can be either plus or minus 3, correct? So if my middle term has to be 2 times a times b, so that's 2 times a is 2x, and to get negative 12, I would have to multiply by negative 3. So that's going to make that minus. So what you need to look at, if this middle term, the sign for that middle term is going to be the middle term here, the sign. Okay? If you notice, this was a plus. This is a plus. So if this is a minus, this is a minus. All right, these are both perfect squares, and the middle term here is minus. So it's going to be something minus something squared. So the square root of m squared is m, square root of 1 is 1. Okay? And remember, you can always check it, work it out, and see if this is what you get. So if I say m minus 1 times m minus 1, and I distribute, I get m squared minus 1m minus 1m, and then plus 1. So it's m squared minus 2m plus 1, which is there. Okay, so you can always check it out and verify. Check your answer. All right, so middle is a positive. It's going to be something squared. So the square root of this would be 3z, and the square root of 36 is 6. Okay. All right. That's our notes for the lesson. Don't forget your I Excel and your big ideas. Thanks.